Thank you. So, is anyone here a city person and not subscribed to the SciPy.org mailing list? Or doesn't turn up to events? Subscribe now.
I subscribe to those.
That's all right. As long as you know about the events, because we run events every single month. And if anyone has ideas about what they want presented or wants to present something, please talk to me or just post something on the list. So, build out. Who knows about build out here? A few people? Cool. I presented kind of a smaller talk on build out and host out last year, and I realized that I still didn't really kind of get into the depth and describe how it worked and how it can solve problems. So I wanted to do a much more in-depth talk about it. So a little bit about the history. It was made by a guy called Jim Fulton, who's a scarily looks like an average guy but invents a lot of stuff. So what problem does it solve? This is the biggest problem I had with coming up with this talk. Our company uses build out for everything. It has changed the way we do deployments, manage our development environments. We can't really live without it. We'd have to change a lot of our processes. But at the same time, coming up with a single soundbite of what it actually does and how it fits into things was really hard. So I thought about all the things that it does do. It's good for isolating Python libraries or isolated Python environments. So that's a little like virtual-env, which a lot of people will know. It helps managing dependencies and versions, so you get a set of the exact versions you want, or you can give a list of exactly the different Python libraries that you want in the particular environment. That's a little bit like pip requires. It also does things like compiles things, compiles C modules, or it compiles things like Nginx, or installs things like Nginx. So it's a little bit like make or ant if you're familiar with the Java world. It creates configuration for you. It helps you reproduce environments, so it's good for doing deployment. A little bit like Chef and Puppet, works a bit differently, but it can be used to solve those same sort of problems. It's good for simplifying templates, so that you don't have to fill out a big lot of boilerplate code for certain things. You can get build out to do that for you. You can use paster script to do similar sorts of things. So what it does, though, is it does all of that in one configuration file. And that's the kind of key to it, is that we're doing it all in one spot with one configuration file that you can check out and build your whole environment with all those different things. So I was actually thinking about this morning. I was like, what's the analogy here? And this morning I realized what we got is gaffer tape. That is what build out is. It's the thing that glues everything together. Now that might sound a little bit temporary and a little bit sort of shaky, but this stuff is used in production environments. We use it for doing everything from Sydney Bus's site and things like that. So as way of an example, a friend of mine was a roadie, and they used to go to this one particular pub, and they had this ongoing joke with the publican there, and they had a bet. The publican bet that they couldn't gaffer tape down their forklift so that it wouldn't move. The roadie won the bet. So gaffer tape's strong stuff. Don't underestimate gaffer tape. There's also the old joke, gaffer tape is like the Force, has a light side, dark side, and holds the universe together. I think there was I missed a word. So build out's a little bit like that. It does have a dark side. Some people get a little bit frustrated, and I'll talk about some of those issues a bit later. So this talk is really about application stacks. These first three are things that we've done. So that's probably my favorite stack right at the top there, where we're using Nginx, Varnish. How many people use HARProxy here? If anyone does load balancing, HARProxy is friggin' awesome. So these are things that we configure, deploy, manage, all with build out. And we do all our Munin stuff using build out. We can take it from one machine, we can deploy it to another machine. with exactly the same environment. There's pretty much anything you want in there. So what we're talking about is this problem space of joining things together, putting them all in the right versions, configuring them all, having something running from running one command. So how does it work? Buildout has an any file type syntax. So you'll generally have something that ends in .cfg. The default is a buildout.cfg. And we've got, you always have to have a buildout section at the top, and you have to have a parts equals. Everything after that is optional. So, but you're obviously not going to get a lot if you don't have any parts to it. So then you've got a whole bunch of these parts. So you can name it whatever you want in the parts section. If it's referenced in the parts equals, then it's going to execute that particular part. All parts have, they don't have to have a recipe, but if they have a recipe equals, then that is a easy installable package, probably on PyPy. So the recipe is what it is a package that says, I know how to do something in build-out world. Then you have a whole bunch of arguments to it. And what happens when you run that depends on what the recipes do. So build-out in itself does very little. It's just using these different recipe plugins to do stuff. So if here's one way you can start using build-out. You can easily install zc.buildout and then go build-out init, and it'll create you a bin directory. In the bin directory, there will be a bin/buildout. There's a part section where each of the different parts will install different bits and pieces. That will change every time you run the build-out. It will resynchronize things. Develop eggs is a special thing for managing eggs that are under development. Oh, okay. Which one do I push? No. Okay. No, still can't. Oh, yeah, there it is. Okay. So the idea is that once you get started, you've initialized your build-out and you've got an isolated environment. So what goes on in build-out stays in build-out. Generally, the recipes should be designed in a way that they install stuff into your local build-out directory so that you can take a build-out directory, move it somewhere else. You can have multiple different build-out directories on your computer, each of which don't interfere with the other. Of course, the recipes can do almost anything, and sometimes they do have side effects. You can get them to install stuff in your package manager if you really want. But generally, the idea of build-out is that all recipes have an isolated environment. There's a general convention that not only do you have like so your changing part of your configuration goes in parts, so your sort of things that you want to install. That's under the control of the recipe, but you might have a /var where you put database stuff which doesn't change every time the build-out runs. And the bin directory is where all the scripts get installed. So instead of having things in your system path, suddenly you're doing bin/buildout, bin/Python, things like that. Okay, so here's the simplest hello world I could think of, and it doesn't involve any Python actually. So we're using two recipes in this build-out. We're using this one here, which is called collective recipe template. All that does is defines where you want the output to go and what the input is. The input could be a file. In this case, I'm just using an inline input. So we're basically just putting echo hello world into a file in the bin directory. And then we want to make it executable. So we've referenced the output there, made it executable. So if I run that, let's not run that. So if you run that, you go bin/hello, it says hello world. So one of the interesting things is this idea of substitution. So you'll notice the syntax here. So what we're doing is we're referencing the build-out section, and there is a hidden variable, something that's generated by build-out itself, that you can expect to find, which is bin directory. In this case, we're referencing something that we can see on screen, so we're going hello world output. So you can make as many of these as you want. There's a syntax where you can just remove that and have the colon, and it will just reference something in the same section, the same part. Now, one thing you'll notice that's difference between this one and this one. Can anyone see what the difference is? Anyway, it's the bit up the top there. So because this references something in hello world, what this will mean is that build-out will go and try and execute this particular part, and it'll say, oh, actually, in order to execute this, I'm going to need this. So then this will actually be executed first, and this will be executed second, and there's no need to specifically say that we're using that. So it's a little bit like make in that regard. So installing scripts. This is a little bit more complicated than it needs to be, but this zc.recipe.egg is the equivalent of easy install. And all it really takes is the eggs here. So here we're using something called Fabulous, which displays kind of ASCII art in bright, shining colors and stuff. So in order to get it to do something, I've cheated a little bit and used this initialization and set up an entry point and so on, so that when you run this, it will actually run this piece of Python here. Normally, you don't need to do that. You can just go, these will define their own entry points and create scripts. So if you have, if you install something via easy install and then it creates a script in your path, this is going to do the same thing. If you have an entry point in one of these eggs, it will create a script in bin, and then you can suddenly use it. So if you go zc recipe eggs equals paster, it will create all the paster scripts in your local build-out directory, and then you can do bin/paster, serve or whatever you want. So, yep. So, I think it's quite useful. Like, this is not something you'd normally want to do, but like, it's really useful to see what is actually happening under the covers. How is this working? So, in the 1.5, it's changed a little in 1.5, but this is roughly what happens inside one of these scripts that get generated. All it's doing is manipulating the system path and calling the actual piece of Python code which represents the entry point. So it's not really rocket science. It's reasonably simple to understand under the hood. So recipes, again, you probably aren't going to be writing a recipe, but I think understanding how recipes work helps you understand what's going on with build-out. Instead of reading these build-out tutorials and say, oh, it installs this and it does this. If you understand how they work a little bit, I think it helps. So here's an example recipe. All a recipe has to do is have a class. Doesn't have to inherit from anything. It just has to have 3 methods. It has to have an init, an install, and an update. So the init is called when the recipe part first gets created and gets passed options, which is a dictionary. So it's getting passed all the arguments that went in. It's getting passed its name, and it gets passed the build-out object, which is like a global state. Then we can set various different things that we want out of the options, say, or just store the options itself. So here we're expecting an argument called input. We're setting an output all ready to go for when we do something, and we're setting a location, which in this case we're using the global build-out state to say we want the bin directory and we want hello object to be created. So then what it does is it's initialized all of them. It's worked out the ordering based on those dependencies we saw before, and it's going and running the install. So it runs the install, does a whole bunch of stuff. It could download things off the internet. It can create configuration files. The key part here is that what install returns is a list of files that should be monitored. So it's a list of files that were created as part of the build-out. Now what that means is that if any of those files get deleted for whatever reason, if any of these inputs change, then this will get reinstalled, and build-out will take care of that for you. Update itself, it's just something that will get run every single time. So if the options don't change, if any of the inputs into this recipe don't change, if any of the files aren't accidentally deleted or anything, then it's the update that will be called instead. So that just gets called every time. Here's something that we use a lot. It's what's called an extension, so it's slightly different in the recipe. And mr.developer is this cool thing that lets you check things out. So you define a sources section, and you can have all these different definitions of all these projects. It can be SVN, it can be Mercurial. And what mr.developer will do, which again, I don't know why it's not switching, but anyway, is it'll create a develop command. So you then go bin develop, check out hello world, or bin develop, update everything. It gives you a whole bunch of handy things to manage lots and lots of different source code projects. And it does this, you've got this auto checkout here, which means that as soon as the build-out's created, it will go check those out. And it does a little thing behind the scenes where it will put those eggs into the develop space within build-out, so they become available to any particular recipe in there. So when zc.recipe.egg goes out to try and get the things, it will notice and say, oh, we've got a developed version that overwrites any other specification we're looking for. There's another way of doing it, which I didn't show here, where you can go develop equals and just point it to the package directory, and that will do the same thing if you don't want to worry about mr.developer. CMMI, this is one that also gets used a lot. So what we're doing here, is we are creating a slightly industrial version of Plone. So we've got our Zope2 recipe, which does a whole lot of things like configure Zope, which is a web server, web application server. We've told it that we want to use our own custom package called Hello World Plone. This won't run, by the way. It'd be nice if I wrote that, but it doesn't exist. We want to use Plone. In fact, if in the setup.py, if I had a install requires Plone in here, then you wouldn't even need to put that. That would all get pulled in for you. We said what address it runs on. We're doing the CMMI for Varnish. So we've told it, go get the latest version. So we don't have to rely on whatever operating system, whether they have the latest version of Varnish. If Varnish has a security patch, we can say, go and get the latest version. A little bit time consuming in that it's going to actually build it. But again, it's the whole thing of we test and develop a version and we know it works in development, and then we roll it out into production using the same build out, and we get exactly the same environment. So we can guarantee what we're working with. And then we've got someone's gone and wrote this Varnish recipe that does all the configuration for us for a standard caching environment for Plone. So we've just said what the back end, so that's just going to act like a reverse proxy going through to our Plone instance. And that references the build location. So we're done. We've got a caching version of Plone running on the system. Although I have noticed they're both running on the same port, so that won't work. So versions of software. You can use a syntax like this, and you can say, I want Plone version, anything above 4.1. Generally, you don't do it that way. You do it more like this. So you have a version section. You can specify the name of the version section, but generally you call it versions, and then you can list a whole bunch of different versions of what you want. So quite important. if you run buildout just by itself with no extra arguments, it will try and get the latest version of every egg. And that's normally a bad thing. It will go and upgrade things. There are some certain things you can do, like prefer stable. I think it's prefer stable or something, where you say, don't get me development versions of eggs. You can do things like turn newest mode off, which says, just give me exactly what you got last time. Don't go out and try and find a new version of anything. But the safest way of doing things is to pin your versions and say, I want exactly this version of this package. So one of the ways that the Plone community, for instance, has solved this issue is that you can use this extends element here, where you can have one build-out file extend from another build-out file, and they've created a versions, or what they call a known good set, which is just another config file with all the different versions in, so that if you are creating a Plone instance and you want the 4.1 version of Plone, all you got to do is extend your build-out from here, and it will give you all the right bits and pieces. Now, version conflicts. This is the thing that kind of makes people cry a little bit about build-out. And I think, to be fair, it's not necessarily a build-out's problem. It's a fault of PyP and how we specify versions of packages. So it's just a packaging problem. What build-out does is it runs through each of the recipes in order, and it says, okay, I need this package. I don't have this package. I'm going to go out and look up the index server, the PyP. I'm going to find the package version. I'm going to download it, and it'll try and pick the latest version. Now, the problem is that you may download a later version of a particular package, and then later on, it gets some other thing it wants that same package, but it's saying, in the setup.py, it's saying, we want less than this version. We're not allowed to operate with anything greater than that. And because of the way build-out runs, it can't go backwards. So it's picked a version earlier on. So it said, we've already picked, zope.component 3.0, but we've got something else that requires it less than that. So it's kind of stuck. Things like aptitude and apt-get and so on, they solve this problem a little bit differently. They have like a universal view of what all the different dependencies are for all the different packages, so they can look at that whole universal view and say, okay, we know exactly which versions to pick at before we start installing anything. But because of the distributed nature of versions with PyP, you don't know until you actually get the package and install the package. You don't know what else it requires. So it's a much harder problem to solve in the Python world. So anyway, there's some ways around this. So this -n is the non-newest mode. Good to always run like that, which means that don't go out and get new packages. You can do this -v, that gives you a verbose option. So that helps you go through and see what things possibly. It's a little bit hard to debug this sometimes because you don't know what asks for zope component, say, originally, and try and work out, well, what's the set of versions that might work. And just pinning versions or using people's set of versions that work. If you're only installing a few different things, if you're not using complicated applications, this probably shouldn't be an issue. Another tool that can help is a thing called dumppickedversions. So what that'll do is if you run it in this mode, it will, at the end of the build out, just say, here's all the things that build out guessed at. Here's the non-pinned versions. So it's nice to kind of see and say, okay, well, just a minute, maybe I should pin some of these versions, make sure that that's not going to change later. You can say dumppickedversions file, and it will, instead of printing it out to screen, save it into a CFG file that you can then extend from or do things with. The way we tend to use this is we will check this into the repository with the build-out file, and then you can do like a git diff or something and see, well, these are the versions that have changed between one version and another. And then you can have sort of one person who's the build master who might upgrade the versions, and everyone else has a slightly modified version of the build out whereby they're extending from this picked versions, which means that they're using exactly the same versions that you ran it with. Macros. Okay, so the idea of macros is we're just saving a little bit of time. We don't have to repeat code so much. We're just saying base instance 2 is the same as instance 1, except we're overriding the address. So if you look at this, what we have here is we have a load balancing version of Plone using reverse cache proxy in about that many lines. So we've got this nice, again, this nice recipe which does sets up Varnish to do the load balancing for us. All we need to do is say what the different addresses are. So there are the different addresses. These are 3 instances are creating. So when this runs, it'll run 3 different processes, which will get round robin balance between them. mr.scripty's one that we created, actually, and we wanted to kind of do a little bit more automation. So what it does is it kind of lets us write Python. It lets us write a kind of a small anonymous recipe right in the configuration file. It's a little bit ugly in that you've got to use this ... here. The problem with that is that standard config ini parsers, with Python, they strip out all the white space in front, so you can't use white space. So when this actually gets generated, all that will get de-indented. But anyway, what we're doing here is we're essentially just using this port space, and we're adding this offset to it. So the nice thing about that is that then we can say each of these is going to access ports. So this will make set options key. So it's going to go through each of these and add the 1000 to it, and that will then work. So it'll be 1080, 1081, etc. And then what we can do is we can do things with that extending syntax we saw before. So let's say we have a staging.cfg. Now suddenly this extends from that base build out we've got, and we've just overridden this offset, and suddenly we've got our whole app stack running on a whole set of different ports. So it's a nice easy way to have a staging environment and production environment all running on the same machine, and they're not running on different on the same ports. Annotation mode is something that people overlook a little bit. It's if you're doing, like we tend to run build outs with up to 10 different files where we're building things like LDAP, and we're building database servers and various different bits and pieces, and we have different environments. We kind of mix in different build out files. So sometimes it's useful to see where all the different values are coming from to debug. And if you run the annotation mode, it gives you this kind of extra line which says exactly where it came from and whether a value is a default value versus a specified value. So if you go to Pipey, there is a crap load of recipes out there. This is just the front page of when you search for recipe. It's kind of interesting. You go and do this on a weekly basis and you get different results. It's amazing to see what's out there. So patching eggs, that's kind of interesting. What else have we got? This is one that I probably should have talked about. We use supervisor D for almost all our stuff, and this allows us, if we say we have kind of a production build out like this one, we would specify in there what the run commands are, and supervisor D would give us a process to start things up and shut things down. Supervisor D is very cool. And that recipe that we saw there just configures it for us. So it's all, again, in the same configuration file. There you go. You can create a whole transcoding daemon. There's a bunch of ones for Google App Engine that'll create a Google App Engine environment for you, so that you don't need to install too much stuff. There's a whole bunch of ones for Django that help you manage Django projects. Almost everything you can think of. So here we can do templates using Genchi if you want. Loads of them. Hostout is something I wrote, which I won't go into, but roughly what it does is you add it to your existing build out, and then it gives you a command that says hostout this definition of the server, go and build that server. It'll hook into the Amazon API and the Rackspace API and things like that, and will create the server if you want. It uses Fabric under the hood to go and do things like install Python, install the build-out environment in a certain place, create users, get everything going. The whole idea is that it takes whatever build-out you're using here, or a modified version of the build-out using here, and puts it over on some other server. We use that for all our deployment. It saves a lot of time. If we make changes, we just click go, and it goes and builds, reconfigures our servers for us. And that's pretty much it. Any questions? Does that solve a problem that anyone has, or could possibly solve a problem? No.
Yeah, we use it. I was wondering how you would compare and contrast this to system-level builders like Chef, Puppet, this kind of thing.
It's quite interesting. I remember going to one of the DevOps meetups, and they were talking about Chef and Puppet. I think they solve slightly different problems. Chef and Puppet, for a start, you have to go and install the daemons around and get them all configured, so it's really good for having the same kind of environment replicated around the place. That on a kind of a push model. This on a pull model, like you just kind of set the configuration and it goes off and does it in the background. This is kind of more where you say you're building an application and you want your custom versions of this and this and this, and you want to push it out. That doesn't really describe the difference that well. So the other thing is the system level, that Chef and so on, they generally will operate on package management and things like that. Again, they can do anything like build-out can. But generally, Chef and Puppet are really good where you are a hosting provider or you are running a large number of servers. The way we use build-out, we need to manage other people's machines, which are all over the place. So they're all in different environments, they're all in different data centers. We push out those changes, we can replicate those changes locally. I can give the production, the development environment to another developer and say, build this out. You can't kind of do that with Chef. You can't say, oh, you know, by the way, and just install this daemon and install everything on your local machine. It's kind of, it fits a different class of problem, I think. Any other questions? Cool. Thank you.